Hello everyone, I hope you are doing great today. So today's video we are going to be discussing some scientific facts so that we can all improve our knowledge together, and I want you to watch this video to the end, like and subscribe to our channel so that when next we post a new video you are going to get notified immediately. So please, I also want you to comment your thoughts on what we're going to be discussing about today, because there are some things that are not altogether clear to me myself, so I'm going to be posing them out as a question. So if you have any answer to them, please write them down in the comment section below. This channel is a channel of facts, and we are here to discuss. Fact number one is that there are 3 billion base pairs in the human DNA. Now, first of all, you need to understand what is the composition of DNA. The DNA is composed of a 5-carbon deoxyribose sugar, a nitrogenous base, and also a phosphate group. So these three combine together to form what we call a nucleotide. So billions of this nucleotide, they pair together to form the DNA, although they associate with proteins also, to form a complex structure that is packed together, which is called the chromatin. So it's a kind of compact compound. It's a large compound. It's also called a polynucleotide. The DNA is a polynucleotide that is interacting with protein. I want you to write the name of that protein in the comment section below if you know what the name is. The DNA is like a polynucleotide that interacts with a protein to form a complex structure known as the chromatin. So the basic thought would be, is the DNA, is it the largest compound in the body? Is it the largest compound in the body? Because we have glucose, we have proteins. They are made up of thousands and millions of monomers. So are we saying that the DNA is the largest compound in the body? Tell me what you think in the comment section. Number 2 fact is that matter is anything that has mass and can occupy space. I know a lot of us knows this, but not many people know that the air we breathe in is also matter. Yeah, the air we breathe in is also matter. It has mass and it can occupy space. That is why, if we hypothetically think of a container that has been totally packed with air, that's fully packed with air, we discover that before any other thing or any other substance can enter into that container, some amount of air need to come out of that container. Otherwise, it will be impossible for any other kind of matter to enter into that container. And matter is in 3 basic forms, which is solid, liquid, and gas. So air is matter. So the air, although we cannot really see the air, we cannot actually touch it, but it is because of the pressure. It is because of the pressure that air exerts around us. That is why it is pretty unfathomable, a little bit unfathomable. Although we can feel it, we can breathe it in, but because we are used to it, you can wave your hand. But if you wave your hand, you feel like a kind of rush that is moving through your skin. But because it is not as thick as a solid, and that solid substance that can easily resist its movement, many people don't really seem to know that it is matter. But actually, air is matter. So matter is anything that has mass and can occupy space. Another basic fact is that an object's mass and an object's weight are 2 different things. Some people confuse mass for weight and weight for mass. An object's mass, according to physics, is constant. So what then is an object mass? I want you to pause this video and write in the comment section what you think an object mass is. However, an object mass is the amount of matter that is contained in that substance. The amount of matter that is contained in that substance. So if there is a ball, or let's say my hands now, talking about the palms of my hands, palms and the fingers. So the amount of matter that make up this palm of my hands is what we call the mass. So and the mass does not change. Whether you take this hand of mine to another planet, another galaxy, it is not going to change. However, what is the weight of a substance? Basically, weight of a substance is the mass of that substance under the influence of gravity. So the weight of a substance changes from place to place, depending on the gravity. Well, the approximated force of acceleration in the Earth is, let's say, 10 meters per second squared, by the acceleration due to gravity of the Earth. So the weight of any matter on the Earth is quite the same in almost all parts of the earth, although there are some parts of the earth where it is a little bit less and it's a little bit more. However, it is approximately almost the same. But if you take a substance, a matter from the earth to the moon, the weight of that matter is going to change. Why? It's because the acceleration due to gravity in the moon is lesser than that on the earth. So the weight of the matter on the moon will be less than the weight of that matter on the earth. Number 4 fact is that the body can make compounds, but the body cannot make elements. Now this sounds a little bit confusing. What are compounds? Compounds are, in a nutshell, substances that are made from one or more elements, and they can be separated by physical chemical processes. So if an element sodium and an element chlorine combine together, so chemically they combine together to form sodium chloride, which is our normal common salt, our normal table salt. So that's a compound. Sodium chloride is a compound. But then what's an element? An element is a substance that cannot be separated easily by physical chemical method. It's a matter. It cannot be separated easily by physical chemical method. You cannot, divide it into other components by physical chemical methods. For example, let's take for example sodium. Sodium is an element. You can't just easily apply any physical chemical method to break sodium into pieces. You cannot just easily do that. So the fact here is that your body can produce compounds. Your body can produce glucose. Glucose is a compound. Your body can produce protein. Protein is a compound, although they are large molecular compounds. Your body can produce a lot of compounds, but your body cannot produce elements. Your body cannot produce sodium. Your body cannot produce chlorine. Your body cannot produce potassium, calcium, all the elements Your body cannot produce them. So if you actually need, because we do need some of these elements in our body as minerals. So if you actually need these elements in your body, you have to ingest them. You have to take them in. Your body cannot produce them. So if you think that fact isn't true, you can just crack your brain and try to think of it. What is that element that the body can produce? Share your thoughts in the comment section below. So another fact is that the period which we use to end a sentence, that period, we used to call it full stop. The full stop in a sentence is millions, take note of what I'm saying now, is millions of atoms wide. The full stop in a sentence, or the period in a sentence, is millions of atoms wide. So for example, when you're making a sentence, I love you to pet channel, full stop. That dot that you use your pen to create on a sheet of paper has millions and millions of atoms in it. And truly, that's mind-blowing. Come to think of it. The full stop you are putting on your book, on your piece of paper, it's millions of atoms wide. Which means if you want to think about the size of an atom, you are going to be thinking way, way, way small. It's almost impossible for you to think about how small an atom can be. And that is what will take us to our next fact. Another fact is that the electrons of an atom, they move around the atom at a speed that is close to that of the speed of light. So an atom is made up of proton, neutrons, and electrons. The proton and the neutron is what makes up the bulky mass of the atom. The proton has positive charge, the neutron has neutral charge, it does not have any charge, while the electrons has negative charge. So the proton and the neutron forms the nucleus of the atom. So orbiting around the nucleus are the electrons, and those electrons are so tiny. If an atom could be so tiny, then you can just think about how small an electron can be. The electrons in an atom are moving so fast around that atom in a speed that is synonymous to the speed of light. So come to think about it as a science student, as a scientist, or as a science student. That electron, does it not lose energy? How possible is it for it to travel that fast? Because if something is traveling at such a speed and it's having a mass, then it's going to be losing a lot of energy with time. But how come these electrons keep on moving around, close to the speed of light, and it does not necessarily collapse into the nucleus? So what is the basic reason for its stability? I want you to write that in the comment section below, because I know that some of you know that. What is the basic reason for its stability? And does that not contribute to the reason why an electron or an atom cannot even be seen by any kind of microscope? I feel that's one of the reasons why. Because if it is moving at such speed, it will be, and considering its mass and its weight, whatever it is, it will be very difficult to capture a single atom to say, okay, this is an atom here. Using any available instrument of humans that we have today, it will be very difficult. The last fact for today is that the electron, proton, and neutron of all elements are the same. Now, I know that this is going to contradict what you popularly believe, okay? But it is a misunderstanding. You are misunderstanding what I just said because of what you know. And what do you know? You know that the number of proton, electron, and neutron in every atom is different. But what I just said is that the proton, neutron, and electron of every atom is the same. I'm not talking about the numbers, I'm talking about the entities themselves, those subatomic particles themselves. There is nothing like a sodium electron. There is nothing like a chlorine electron. There's nothing like a magnesium electron. Electron is electron. Proton is proton. And how do I prove that they are all the same? Is that two atoms can share the same electron. An electron can be transferred from one atom to another, forming electrovalent bonding. So no proton, no neutron, no electron of any atom is really different from another atom. The only thing that differentiates one atom from another is the number of proton, neutron, and electron that makes it up. So thank you very much once again for watching this video, and I want you to like and subscribe to our YouTube channel so that this video can be recommended to more people. And if you have any thoughts or anything you want us to discuss about or make research about, you can write it down in the comment section below, because here on this channel we discuss facts.